Friends, good morning. In this video, let us discuss the next long answer question from chapter 8 Oscillations. So, the question is show that the motion of simple pendulum is simple harmonic and hence derive an equation for its time period. What is seconds pendulum? Three parts are there. The first part, to show motion of simple pendulum is simple harmonic. For that, consider a simple pendulum. Simple pendulum means a bob tied with a thread and one end fixed at a rigid support. Such arrangement we call it as simple pendulum. Now, displace the simple pendulum to one side. Okay, the displacement you note as x. Let L be the length, M be the mass of the pendulum or bob. Now, bob is making an angle theta with the vertical. Okay, now the weight mg on the bob acts in downward direction, gravitational weight. It will be towards the earth. Now resolve mg into two components. One along mg cos theta, and this mg cos theta balances the tension. Okay, tension means the force which provides stiffness in the strings. Next, other perpendicular to mg, that is mg sin theta. And this mg sin theta, when bob displaces, again it comes towards the mean position. The reason is restoring force. So m sin theta provides the restoring force. Such restoring force F equal to minus mg sin theta. Why we kept minus? Because this is opposite to the displacement. Displacement is in this direction, positive x direction, and restoring force is in a negative x direction. But from Newton's second law, we know that F equal to ma. Substitute here. You will get ma equal to minus mg sin theta. Strikes off, a equal to minus g sin theta. Now here from figure, so consider triangle. What is that? OAB. This one we are considering. OAB. So from that sin theta, what we can write? Opposite side x, hypotenuse L. Right? So now substitute here. Minus g x by L. Or just I'm writing the same thing as minus of g by L into x. Or a equal to, or I can write a proportional to minus x. That is, a is directly proportional to the displacement but in opposite direction, which shows that the motion of simple pendulum is nothing but simple harmonic. Right? Now next part is derive an equation for its time period. Okay, the equation, second part, equation for time period. Now here we got a equal to minus g by lx. Let us write that. Okay, a equal to minus g by lx. In my last video, we talked about simple harmonic motion and we derived a formula a equal to minus omega square x. Put it as equation 2. You check my last video, you will get this. Now compare 1 and 2. In place of a is there minus minus x. And in place of omega square, what is there? G by L. Send root through this side, it becomes under root g by L. Omega means what? 2 pi nu. Omega is nothing but 2 pi nu. That is equal to under root g by L. What is nu? Frequency. Omega is angular frequency, nu frequency. 1 by time period, no. Okay. So substitute. In place of nu, 1 by t. Under root g by L. G, acceleration due to gravity. L, length of the simple pendulum. T, time period. Okay, time period definition. Time taken to complete one complete oscillation. Okay, time taken by the particle or simple pendulum to complete one complete oscillation. Now, just write the reciprocal. T by 2 pi L by G on both sides. Now T, 2 pi, you send this side, L by G. So this is the required equation for time period of simple pendulum. Now what is the third part? What is seconds pendulum? Right from diagram, the every point carries marks. Seconds pendulum. What is seconds pendulum? The pendulum whose time period is 2 seconds. That is t equal to 2 seconds. We call it seconds pendulum. So this is all about the second long answer question from oscillation chapter. Practice well mathematical part in a very easy manner I explained, and write exam perfectly. Thank you for watching my video. If you like it, share it, subscribe it. Yours, Reshma Physics.